All right, cool. All right, well, thank you all for coming to today's Corundum developer meeting. So let's see. Mainly what we have for today are just a couple of status updates. So let me go over the list real quick here. So we got the Zinc Mps Oc board support merged. So huge thanks to Emily for helping out with making that happen and putting together that design. I also got, let's see, yeah. So that's the biggest thing that's changed recently. Then I'm going to be working on some PTP clocking related updates, and then we got most of the same updates from before: the very blank descriptor support, some updates to the queue selection logic, management software, and some PHY level stuff. So big topic for today is the Zinc Mps Oc support. So this one, the idea here is we're adding support for running with SoC style devices instead of connecting to a separate host computer over PCI Express. So for SoC support, the idea is that we'll connect to a processing core on the same device over something like AXI. And that's what we have right now for running with the Zinc SoCs. So Emily has put a lot of work into getting the driver modified and getting an example design put together for the ZC106, and it looks great. I got my ZC106 over here. I got the whole thing running on there, and the performance looks pretty good. So obviously, there's I think a few corners that need to be cleaned up a little bit. One thing I'm working on is a port for the ZC102, just to make sure that I know how to create a new Linux project and whatnot. That so far that hasn't worked yet. I have a few kinks to work out. I think on the Linux side, doesn't want to boot. I probably did something wrong with setting up the project, but that'll be the idea, is to also have a port for that board and potentially some other ones. We'll see. One of the issues with the current ZC106 design is that the exported block diagram from Vivado is locked to a specific Vivado version. So I've been working on basically reworking that so that you can run it on whatever version of Vivado you happen to have installed. Because right now I think the design is targeting 2021.1, which is not quite the latest version. The latest version right now is 2021.2, at least until they release another version of Vivado. The other thing I'm looking at is to run it with a slightly faster core clock, just to see if that makes any difference in performance. This is because the only reason that we run a 250 on most of the other designs is because that's the PCI Express user clock. So we'll have async FIFOs on the Ethernet side, and then on the AXI side, on the PCIe side, we'll run synchronous. So same thing with the Zinc Mps Oc. We have async FIFOs on the Ethernet side, so we might as well run the core clock effectively as fast as we can get away with. So the design is close timing. On the ZC106, I'm running into an interrupt related issue. I think I sorted it out, but I got to rebuild it and then test it. And then on the ZC102, it's I need to figure out how to get Linux to build properly for the ZC102. So progress is being made, though. So hopefully I'll be able to get that squared away later this week, and then we'll have support for both of those two boards done up properly. All right. So the next thing, yeah, and again, major thanks to Emily for helping to make that happen, because I'm not definitely not very familiar with working with the Zinc devices so far. All right. So Ptp clocking updates is the next topic here. And basically the gist of it here is what I want to do is take the Ptp hardware clock component and run that from a more stable clock source. So right now it's running basically in the PCIe user clock domain, or on the Mps Oc devices in a clock provided by the ARM core side effectively. And at least on PCIe systems, that host clock is not necessarily very accurate or very stable. I've had systems where that clock has been off by percent. And I don't know what kind of oscillator is coming from in terms of the temperature stability and whatnot. So yeah, for timekeeping applications, it probably is not the most sensible clock to use. So what I want to do is take the PHC and pull that into a separate clock domain so we can run that on basically whatever clock you want. You could run it on the, you know, PCI Express user clock if you want, or you can run it synchronous to like the transceiver reference clocks. And if you do that, then those are going to be much more accurate oscillators, usually within, you know, a handful of ppm. Like an Ethernet link will tolerate, you know, plus or minus 200 ppm, I think, between the ends. So that means one could be 100 ppm fast, the other could be 100 ppm slow, and it'll work. So those have to be within 100 ppm. I think they're usually like 50 ppm oscillators, something like that. So yeah, that would definitely be a better clock source. The other potential consideration is that if you want to do something like Syncki or White Rabbit or whatever, in this case, you're actually distributing the timing information using the transceivers themselves by adjusting the transmit reference clock to align with the receive clock, which ends up being, you know, much more accurate than just exchanging timestamps and doing nothing else. If you're going to do that, then you don't tune the clock by adjusting the period register in the hardware clock. You're adjusting the frequency of the transmit reference clock instead, using either a VCO or a fine PLL divider. So for something like that, you know, you need to be able to control the clock. So that's where running the Ptp hardware clock in that clock domain is going to be potentially a much more useful solution. So yeah, I'm looking at what it's going to take to do this. It looks like I just need to add some clock crossing logic on the control signals to the hardware clock. For the most part, I have Ptp CDC modules all over the place for taking the Ptp clock and passing it through to like the Ethernet transmit and receive clock domain. So the main thing I need to do is add one of those for driving the, you know, PCI Express user logic based on what the Ptp hardware clock is doing. So shouldn't really be a gigantic set of changes. And I guess the other thing I didn't mention in this slide is that what I want to do a couple of other things. One of them is to adjust how the clock period is specified. I did some brainstorming on this a while ago on the Slack channel, but my thought is to, instead of basically specifying the register values for the Ptp hardware clock module, what would make more sense is to try to come up with a more general representation of what the clock period is. And one way is just to like provide integer number of femtoseconds or something, or to use, you know, a real number, or another option is to use basically fractional representation. So you specify a numerator and a denominator, and then that's, I think, going to end up being the most accurate, because you can compute, you know, what the remainders are exactly, and then plug that into the Ptp clock so that it will maintain exactly the ratio that you want. So I'm going to look into to implementing that as part of doing this. And then one other thing that Emily was asking about is the, you know, having some ability to know what the core clock frequency is. And obviously one option is just to add some parameters for that. But if we're going to have this higher stability reference oscillator, it might make sense to, you know, just measure what the core clock frequency is, and have that exposed in a register. So it looks like we should be able to do that just by adding a couple of counters. I still need to figure out where that's going to live. I'm thinking that will live kind of at a higher level than like a you know, clock information block or something like that, which can be present if you want that capability. And then that'll give you a, you know, very precise measurement of the core clock frequency. So that means that if the PCI Express clock is, you know, off by a few percent, then you'll be able to compensate for it. And I guess I should mention that's kind of a funny story. We ran into um, an issue when we were doing some benchmarking of a test design on a VCU 5025 board installed in one of our, one of our development machines that came from some project at the university. I don't know exactly the history of these, but the machines were built with like one of the first CPUs to support PCI Express Gen 3, and they were pieced together from parts. So they had like some sort of gaming motherboard with the CPU installed in there. And when we were benchmarking, all of our results were like a few percent higher than what the theoretical computations should be. And we kept identifying little cases to, improve the accuracy, but we were always like 3% too high. And like, something is weird here. And eventually we realized that the motherboard was clocking the PCI Express interface 3% faster than it was supposed to. So because we're running everything in the PCI Express user clock domain, the clock was, 3% faster than it was supposed to be. So yeah, it wasn't running at 250 megahertz. It's running quite a bit faster. So if we add some registers to measure that, then you'll know. The other thing I've noticed as well is that most of the machines that I've run Corundum in and done like a PTP time synchronization, the PTP clock is like a quarter of a percent or something like that slow, like not a few ppm, like it's pretty far out. So if you're trying to run your schedulers or something and be very accurate in terms of the time that you're keeping locally, then that might need to be compensated for. Anyway, enough about timing stuff. Let's take a look real quick at a couple of these other things on the to-do list effectively. So variable length descriptor support is something that I've been talking about for a long time. Once a couple of these other things are squared away, I'm going to get back to working on this. Actually, I guess, I didn't put together a slide on this. I should have created one though. I've had a couple people ask about doing effectively Q pointer write back, where you can avoid the MMIO read on the fast path by writing the Q pointers back out into host memory. And there's a couple of pieces that are required for that. So one of the things that I have implemented so far is to add support for immediate writes to the DMA engine. So you don't need to write the Q pointer out to the internal memory and then request that to be written out into host memory. Instead, what you can do is just send it to the DMA engine effectively in place of the internal memory address, and then it'll just write it out. And then the other piece that I need to do is add some additional components to the queue management logic to keep track of effectively an address per queue for where this would be written out into host memory, and then the logic to actually perform these writes. So I think I have the DMA engine modifications necessary for the queue write back support, for the queue pointer write back support to work. The next step is to add the necessary queue management logic to actually generate these writes. And what I'm going to do is roll that in with the variable length descriptor support. So when I rewrite the queue managers for variable length descriptor support, then I will also add this queue pointer write back functionality. All right, so RxQ selection logic. This is another thing that I know the folks at MLE need this. I've been taking a crack at making a few modifications to how the receive path works, so we have a nice place to implement this sort of thing. Originally, I was thinking about implementing this effectively before the packets get handed off to the receive engine, or effectively before the packets get handed off to the DMA engine on the receive path. But what I'm actually thinking is going to make more sense is to drop this more into the receive engine itself. So the idea is that once the packet has been, spooled in the internal memory, then the receive DMA engine will hand off a little descriptor that contains some information about the packet, including, the TID and T user values for that packet, and then that will get passed to this queue, to what I'm thinking will be a new module, a queue mapping module, which will implement this this remapping, taking the TDES to the RSS hash, and a potentially an offset value for each queue, which is along with the app mask and RSS mask, which will be determined based on registers determined by the TID setting. Take all that information, combine it, and give you the destination queue. So all of that, we can do that in a module that will be instantiated inside of the receive engine. So the other thing I'm thinking about doing as well is reworking the receive DMA engines to be a little bit more efficient, because right now I'm managing the all of the addresses and the receive buffer space inside of the receive engine. I think it makes more sense actually to have the DMA engine handle that, because the DMA engine, it knows how big the packets are as they're coming in, and it will just, it can immediately start receiving the next packet after the first one ends. And as a result, we'll get better utilization of the internal receive buffers. Potentially that doesn't make as much difference, but it could potentially improve the performance a little bit. So this will kind of, dovetail with that a little bit. Once we're getting the descriptors for these packets coming out of the DMA engine, then we can do the remapping right there in the receive engine, and then do the receive. So I've been thinking about this architecturally. I think what I'm going to do is, for the time being, table rewriting the DMA engine to do the memory management internally, and just get this queue remapping block written and integrated into the receive engine. So we'll actually be able to run this effectively with using the TDES field from the application section for determining the queue. So progress being made on that front as well. All right, and then we have management software. This is something that's unfortunately kind of been backburnered for a while, but it's looking like this is going to be a more important piece in terms of interfacing with the transceivers. I had somebody on Slack also asking about running, I think, the X25 design 10G and not getting a link. And my assumption is that's because that we need to turn off CDRs in the QSFP28 modules when you want to run them at 10G. So that's one of the things that I'm hoping to support in the management software is when you change the link speed, it can also poke at the optical modules and change various transceiver settings, including turning off the PLLs. So yeah, this is definitely on the to-do list, but I'm going to get a couple of other things squared away before I get this this fully implemented. Right, and then also related to that, we have the 10G 25G switching. That's going to be implemented and sitting in these in the software as well. Yeah, but again, this does work in the hardware. The trick now is getting the kind of management and control side implemented. And yeah, and then going back to the to-do list for the stable release, let's see. I guess we haven't had much movement here on any of these other items. The variable length descriptor support, the self-contained checksum offloading, and the on FPGA management software. But we have made progress in terms of getting this SoC device support. So that's definitely a big, I guess that's more of an item that was on the long-term roadmap that we knocked off. So that's good progress. All right, so that about finishes off all the status updates I have. Does anybody have any questions or comments or concerns? I mean, I'm sure MLE has some comments. I'm not if there's anybody other than MLE that has any questions or comments, we can go with them first before turning the meeting over to MLE. No? All right.
Okay, so I guess I can start with the first topic.
Sure.
Just a quick one regarding link state. do I remember correctly that you plan to expose the link state via the softcore?
Yeah, I think that's kind of what my plan was. I can probably expose that through some other register as well. So I've been mulling over adding some kind of phi control and status registers. And that could potentially include the just whether the link is up or down. I don't think I'm going to add any registers for like controlling the link speed. I think the idea will be to offload that to the soft core. But I think just if we're going to expose like the block locked bits or whatever, or potentially some filtered thing, we could just distill it down to a single kind of link up, link down status bit. I think that could be a pretty sensible thing to expose.
Yeah,
and
okay.
Then the driver can read that regardless of whether there's a software present.
Because currently we are thinking about kind of adding a quick solution to get a link state via a custom register block. And so I just wanted to confirm, so if in the future the real solution is coming via softcore, or but now you say might also end up in registers.
Right. Yeah. I mean, the thing was with the softcore, I don't want to, or with things like changing the link speed, that might be like highly board dependent in terms of what operations need to be performed and whatnot. So that should go in the softcore. But for things like reading out the link state, I mean, we could certainly have the softcore do it, but my thought is that if you don't need the softcore functionality, you could potentially make that optional and turn off the softcore. And then in that case, how would you read like the link status? So it might make sense to have a small amount of capability of doing that sort of thing from a standard register block. So I've been kind of waffling back and forth, what's going to make the most sense there, but also haven't had time to sit down and properly hammer out an implementation. So
okay, so because we're currently looking at this, so perhaps we kind of come up with some kind of suggestion.
Yeah, sure.
And then we can talk about it.
I guess the other thing that I was trying to figure out too is if there's a nice way to expose like the link capability, like what kind of interfaces are available. So, is it 10G interfaces? Is it 1G interfaces? Is it switchable between 10G and 25G? So what might make sense is to have like some, phi information registers, basically. So for each phi, you could have, one register indicating, what the phi is capable of in terms of, what speeds it supports. I don't know if there's like a standard encoding for that. Probably not. Might just have to define something. And that way ETH-tool can report that. And then we can have another register that indicates some, basic status information. Potentially we could expose the current link speed, maybe, and then also just whether the link is up or down. And that's probably about it. I mean, I think, going beyond that, you could start getting into really, board specific stuff.
Yeah. So for us, the kind of priority number one is the link state. The link speed is not that important since we only have one at the very place I'm thinking about. So we kind of, can get away with kind of hard coding it for now.
Yeah, but anyway, if you talk about phi status, so there is a phi device driver subsystem in the Linux kernel which takes care about phis. And there is standardized operations on phis and reportings and everything.
Right. I mean, I guess if you wanted to use that subsystem, then you would have to, figure out how to talk to a phi. So I guess it's one thing if you have a phi that you're hooked up to via MDIO or something, maybe that would make sense. I think that's potentially one of the current concerns with the current phi that I'm using, is that it doesn't have, a control register space or something like that that's implemented in a standard way. So you can't just, connect that up and then the driver works. And I
No,
also
no,
don't
you
think, like,
have
the
to
Xilinx
provide your own
CMAX or
driver,
anything like
right?
that. You have to provide your
But
own
you
driver.
could,
Right.
yeah,
Okay.
you could provide your own driver, and to the upper layers there is a standard interface. So
Gotcha.
you need to also have a hook to hook together the MQNIC driver ports, let's say, to the FIS.
Right. Okay. I guess that's I'll take a look at that then. I'm not familiar with that particular subsystem. Maybe there's something something particularly interesting in there. All right, well, that's not a big deal. But I can definitely, if you guys are looking at that, I can definitely move that up on my priority list to make sure that that we can get something usable relatively quickly. I guess if you guys are up, but one other thing I can ask about real quick is what the procedure is for creating a new Petalinux project using your, PS make setup. Is it you basically just create one following the documentation and then you add the make file and that just runs it?
Yeah, yeah,
Okay.
that's the way to go. Yes.
Okay. Right. Because I've been trying to get the thing running on the ZC102, and my progress so far has been that Petalinux doesn't run on it for some reason. Or the one that I put together for running on the ZC102, it doesn't boot. If I like the FSBL doesn't even run. But if I take the SD card from my ZC106 and put it in the ZC102, then the FSBL does run and I get some output over the serial port. Obviously, it doesn't boot because it's a different FPGA. So that's been a bit of a head scratcher so far. I must have done something wrong, but I
Okay.
don't know what the heck.
So not
would
even
affect
the
that.
FSBL output is coming out of the serial port.
Yeah, and I get nothing.
That's strange.
Yeah.
Perhaps some strangely formatted SD card.
Oh, I thought that could be an issue. I copied the files from the ZC106 SD card that I have to the ZC102 SD card, and then it tried to boot on the ZC102. I mean, obviously it failed because differences with the FPGA, but the FSBL ran, so it's not the formatting on the SD card.
Okay. I mean,
yeah. What I'm trying now is I'm just starting from scratch in terms of creating a new Petalinux project, and then trying to get all the stuff imported from the other one. I'm not sure if there's any settings in there that could affect the FSBL.
Well, yeah, I mean, yeah, you never can be sure. But one thing which is specific is the I don't know. I don't remember the setting. It's about the it's not host name, system name, something like this. And there's a specific string there you have to put in this setting.
Right. Yeah.
Then
So I
pulls
actually
in a lot of board specific stuff in the device tree. One point. I don't know if I don't think that pulls in stuff for the FSBL though, since for the FSBL the settings are coming from the XSA file.
Okay.
I guess there are settings for the ZC102 actually, because in there are a couple of RFs interconnecting various external interfaces to the PS transceivers, for example, and they can be switched or configured by FSBL switches as well.
Okay.
So I would recommend just create a new project and base it on the reference for the ZCU102.
Right. Yeah. I guess I need to probably go look up some of that other reference information. I did find the that setting in the Petalinux config, and I did confirm that after changing that, it is pulling in the device tree files for the ZC102, but still didn't work. So
Yeah, I really think that the XSA file is crucial here.
Right. Yeah.
I mean, the FSBL is just a bunch of C files plus header files,
Okay.
I
So
guess,
so if
which
the
are
FSBL
generated
is not
from the
working, then there
XSA
must be
file.
something wrong with that XSA.
That would be my first guess, at least.
Well, so how do you tell Vivado what board you're using? Because if the FSBL is coming along with the XSA file, then Vivado is going to know what board.
Yeah. Yeah,
And
in
neither of
the
these
board
projects
selector
have the
next to
board
the
set.
device. Oh, okay. No, there's a explicit board selector in Vivado.
Oh, when
Right
you
in the
create
dialog.
project, you're creating the board level project.
Yeah, there are two options. Either you select the device you're using, or you select the board you're using. I guess
Okay.
two
I've
tabs
never
or
bothered
something.
with the board level flow. I always just select the device.
Yeah, yeah.
don't
In
even know
these
if I-
cases, it pulls in a whole lot of settings for the PS dedicated to
see,
the
okay.
board itself, or at least if in the block design you then click on this automation thing which is offered. You add the PS block and then it offers automation, and this automation, if you use that, I think it will pull in a lot of board specific settings from the board setting.
Right. So with the ZCU 106 design, I'm just looking at the make files here. Oh, because the design doesn't need to be set up that way. You're talking about it. This is mainly in terms of the configuration for the blocks in the block diagram. It doesn't affect the project significantly. So you just need to create the block diagram with Vivado set up that way.
Yeah, I would argue that most of these board specific settings are relevant for explicitly for the PS block for configuring the ARM chip SoC and all its MIO pins.
Well, yeah. I was setting those based off of what the documentation said, basically. Just looking at the docs and transferring it over.
Yeah, I mean, that should result in the end should result in the same thing.
So I'm looking at the ZC 106 design that we have in the repo right now, and this one doesn't list the board. It only lists the part, the XCZU7EV, whatever.
Yeah, I mean, that's
this one
possible.
Builds and runs correctly. So.
Yeah, it's possible. You don't have to do that, as you just noted. It's possible to do it by hand, but you can also
this is the design that you guys put together.
Yeah, right, and it kind of ended up because you can take the settings and kind of do it manually, have them the same, and then export the thing. I mean, the tickle file is completely exported from Vivado, generated from settings which were derived from a board setting previously. So all settings are, dedicated to the board because they originate from in the beginning setting the board. But in the end, you don't have to set the board again if all PS block related settings are correct or sufficient. Or I mean, if nothing is coming out of the serial console, then I guess the first thing is to check is the correct UART selected.
Well, so like I said, if I take the one from the ZC 106, then it works, and I get output there. So
yeah, which means that both boards use the same MIO pins for TXs, and the same UART hard IP.
Right, and I think I should have it set up with the same pins in the block design. So anyway, I'll iterate on that. I just wasn't sure if you guys might have a few specific things to look at, but okay,
Yeah.
so
I
attempting
guess
to
the
create a,
easiest way is to really start with a new dedicated Vivado design, selecting the board instead of just a device, pulling
Right.
together a block diagram, doing the automation thing, which does all the settings from the board specific selection. And then it's one question of just reproducing that every time, or just taking these settings and don't bother with any board specific setup in the make files.
Okay. Yeah, because when I did run into one weird issue when I was trying to get the, my rebuilt block diagram generator TCL script working for the ZC106, is it would get into the FSBL and then it would hang right when it was trying to load the FPGA configuration. And after doing some poking around online, it seemed like there's some sort of an issue with the DRAM, and they have like two different variations of modules installed on the board. So depending on which one's installed, you got to configure it differently. And they actually added some code to the FSBL that you got to control with a TCL parameter that's attached to the the Zinc UltraScale PS block. And it's not exposed in the UI. You have to literally go into TCL and flip this switch. And I noticed that since I created one totally from scratch, it was not set, but it was set in yours. So I guess you guys didn't set that manually. You probably created this as part of board level flow, which presumably would have set that. So okay.
I cannot say for sure. Maybe the point is sometimes Xilinx offers board settings for older boards, for I don't know, pre-production boards, and so they might have multiple of these board specific settings, which then select different options. I mean, in this case, we are in this case even working, I guess, with a ZC106, which has even an how it's called, engineering sample device.
Oh, okay.
Which complicates things even further because they are not supported anymore. In the JTAG downloading toolchain. You kind of have to work around that and say, yes, I know what I'm doing. But similar things happen with the boards themselves, as you said, different RAM chips. That's always tricky, and that's also kind of the reason for us that we say we don't try to generalize the PS block here, because it seems really version dependent. I mean, it would be nice to get it version independent, this tickle file.
Yeah, I mean, I think I actually almost have it working for the ZC106. I ran into an issue with the interrupts where so I got it to build, I got it to load on there, the driver loaded and everything, but only the first IRQ channel is working. It looks like I didn't do something quite right in terms of how the block diagram is set up from the TCL script. So and for some reason the IRQ signal ended up being 1 bit wide instead of 8. So I don't know what happened there exactly. The more I deal with the block diagrams in Vivado, the less I like them. And also the same kind of thing with the Zinc devices. The more I deal with those, the more annoying they seem. So anyway, but I think if I can solve this, then it might actually work. And the other thing is this one is running with the 300 megahertz internal clock, and it closed timing. So that's a good sign.
Okay.
I mean, see if that does anything to the performance. I'm not sure where the bottleneck is there. So
The next topic is then the Peta Linux thing because the project, because in the end that's also version dependent more or less, and I think Xilinx doesn't even support upgrading. At least I never bothered. I mean, if I'm moving to a new version, I'm always kind of setting up a new project. I never really try to use any upgrade procedure which might be there.
Interesting. Okay.
So
I actually built this under 2021.2, both Vivado and the Peta Linux. And aside from the IRQ thing, which I'm hoping to get sorted out soon, it almost worked. So
I mean,
maybe there just isn't enough stuff in there. Maybe there's more associated with the ZC102 that needs to be, dealt with on some level, and that might be more complicated for some reason. So maybe the ZC106 works fine, but the ZC102 is a different story. Not sure.
In terms of Peta Linux, they changed a lot of between I think the 2020 versions and the versions from last year. They really changed things in Peta Linux project. So, and I think it's just a coincidence that the difference between 21.1 and .2 is minor.
Okay.
As soon as they move
between the minor versions is potentially less of an issue, but in general,
could be
that's not something to be relied on.
Yeah, I mean, one thing I can think of is the generated layers, which have version information in them, which tells the build system I'm compatible with a Yocto version something. And when they move Peta Linux onto a new base, a new Yocto version, then that version information needs to change, or you have to say, this layer is also compatible with name. Just one example, and it really depends on what they change between versions. So I can only say I never tried any of these upgrading things.
I see. All right. Well,
I know that's frustrating because I would also like to have a project which works in any version, at least, which which has documentation which says, okay, I'm working there, and if I'm not working, I'm spitting out a sensible error message or something like that.
Yeah, I mean, I guess from my point of view, it probably the Peta Linux side of things is maybe less important to make version independent than the FPGA side of things, because I like to be able to just build all the designs and see if something is failing timing. Unfortunately, I don't really have provisions right now for building specific designs with specific versions of the tools. I just build everything with the version I have installed, which is usually going to be the latest version. And by avoiding as much of the vendor IP as possible and just generating everything from TCL, that seems to be working pretty well for keeping things, version independent. Probably not a magic bullet, but so far at least it seems to be working okay. For Peta Linux, I mean, that's more, I guess, when you're trying to run on a specific board, then you would have to build both the FPGA design and Peta Linux. And if you have to load up specific versions just to build that, then I guess that's what you got to do. So, yeah. All right. Well, I'll try a couple more things in relation to the ZC102, and we'll see. Yeah, Ulrich said in the chat that it's been delivered in versions with different RAM SODIMMs, and that's, I think, the parameter that I was talking about that's got to be set in the on the PS block. It's a PSU dynamic DDR config EN. and it's not visible in the GUI. You got to set that through TCL. And it seems like it might be specific to the Xilinx dev boards. According to one of the piece of documentation I was looking at, you got to have the memory module set up the right way. And it only works with DIMMs. If it's component level stuff, that doesn't work, because it looks at the SPD EEPROM or whatever to figure out how to set up the module properly. Anyway, let's see. What else is there to discuss? Are there any other questions from anybody about anything? See, I see Gray is on here. I noticed that you posted the some of the modifications that you've made to the driver, right? The adding support for this memory management, or what was that? The memory pool. You might be muted. Still muted. Oh, I'm hearing an echo. Maybe.
Perhaps the wrong sound device is selected.
Yeah, you would know a thing or two about that. Maybe have a mute switch on your microphone, or the microphone is muted in your audio settings. Well, I guess we can come back to Garay maybe once he figures out what's going on with his microphone. Let's see. Rack my brain to see if there's anything else that's come up recently that should be discussed. Well, I guess you guys at Emily have also been working on that DPDK driver, right? Is that kind of backburnered at this point, or are you guys actively working on that? Joachim, were you going to say something? I think you're muted.
Yeah, right. Actually, I thought Uli was going to say something on this.
I'm trying to be muted as long as I can, because I'm right now at the train station and it might be noisy here.
Seems okay at the moment.
Yeah. So I guess I mentioned that in the post that it's on a back burner for like a couple of weeks. So right now we are focusing on integrating everything together and bringing up our PCBs. So that's why I'm traveling back today. I was working on this in another lab. So yeah. We will revisit this definitely like after Easter, I guess. That's on early May, end of April, something like this time frame.
Okay.
So there were some comments from your side, and yeah, we will look at them. So there were some quick ones like formatting, and some more interesting ones, let's say. So we will visit those as well.
Right. Yeah. In my view, the most important thing is to get that, sanity check code in there, just so that if somebody tries to run it with the latest version of the FPGA design, it doesn't totally blow up in a weird way, and it just instead refuses to load. So, but yeah. All right. So we'll be revisiting that in a few weeks. All right. Sounds good. I'm not sure. I know there's a lot of people who are interested. Oh,
right, and that was what I wanted to refer to. So if anybody have additional comments or thoughts, maybe additional enhancements. So go and write a comment, open issues, whatever, and we'll come back to this.
Yeah, I know that there's a lot of people interested in DPDK support. I know what Adam, John, I think you guys you sounded pretty interested in that. I don't know if there's anybody else on here that's that is interested in screwing around with DPDK. But
yes, one of our colleagues is trying to work on that. He's here. Can you say something, Ali? Can
no, Ali?
yes, yes.
Yes, actually, we are trying about implementing a device driver. As it needs to be written with PCI Express, we need to make the latency lower. So there are lots of methods, as we read from the papers. We are just reading papers now. After that, we try to obtain some measurements and see if it will work or not.
Okay, so you're building some custom project or custom product, or this is using Corundum, or?
Actually, our first mission is to know to get the information how we can write this device driver. After we get that information, we can merge it to the Corundum.
Okay, so this would be for, updating Corundum in some way. Okay.
Yes.
All right. Well, that sounds like it could be an interesting project. Yeah, if there's so you guys are mainly interested in trying to reduce the latency, right? It sounds like the lowest possible latency, basically.
Yes, the main reason is to reduce latency.
Right. Okay. Yeah, I guess I'm sure part of that's going to be the driver, but I think another part of that is probably also, the actual FPGA design. So I guess one thing I will mention is that,
Yes.
I haven't really designed Corundum specifically to be, as low latency as possible. It's more designed for, trying to get a reasonable throughput and getting, control over the traffic. So, I mean, reducing the latency is certainly something that could be useful. But I guess if we're going to do something like that, we got to think about what the trade-offs are. So if there's changes that we can make that don't really have any other side effects, but reduce the latency, yeah, let's certainly do that. But if we want to make like or if you guys need a super low latency design, it might make sense to, almost create like a fork or something like that, which does make some of those trade-offs possibly. Anyway, certainly something worthy of discussion. Are you guys working with a DPDK driver? Is that kind of the idea, or are you working with like a standard Linux kernel networking driver or something else?
We are doing a user space Linux drivers now. We are not implementing it for DPDK.
Oh, user space drivers, but not DPDK?
Yes.
Okay.
A custom user space Linux driver.
Okay. Gotcha.
The driver will be used for our custom FPGA design, which is very different. It's similar to what Bob told us before, but in the future, we want a product like we will be using something similar to Corundum as well, maybe in the future. But currently, we are using something very lightweight. I mean, its aim is not very high throughput, so we are trying to reduce latency at this point. But at second step, maybe yes, we are doing that. I think Bob knows what we mean.
Yeah, those guys are also definitely experts in doing low latency stuff. Yeah, okay, so you're making a totally custom design. Got it. All right, that makes sense. Well, hopefully you can get all the kinks worked out of that and make it work.
Thank you.
All right. So did Gray finally get his microphone working?
I think it's working now, right?
Ah, there we go. Yes, we can hear you.
Yes, we can hear you.
Okay, good. So I just sent a message on the Slack channel, and I just sent my module for Evgenic driver for Linux, and I'm trying to use the page pool in Linux, and there's some examples of other network drivers that use it. So I tried to copy what they do, and I have it sort of working, but there's a memory leak, so it sort of runs out of memory after a while. So, but I get the performance up a bit using the page pool. One question I had relating to that was, it looks like with the MSI, it's showing up as 32 interrupts. And I wonder if this is somewhere in the FPGA code, and if we can increase that.
MSI is limited to 32. At PCI Express doesn't, that's the maximum. So to get more than 32, we have to go to MSIX, which is implemented differently at the PCI Express level and how that interfaces with the host. Something I've been thinking about doing for a while, but it is a question of how to integrate that with the rest of the setup. I think MSIX, you can basically go as many channels as you have bar space for, because for every channel you have to store like an address and a value to write to that address when you trigger the that interrupt channel. So
yeah, I see. I think that's probably the next barrier I'm going to, the bottleneck I'm going to hit next is.
How many channels do you need ideally?
I don't know. I might have to go up to like 128 cores. So.
Okay. Well, I mean, yeah, we can certainly.
And how different is MSIX from MSI?
Totally different. So the way MSI works is it uses an entry in the PCI Express configuration space, and basically there's a field where you put, you as in the operating system would put a destination address that corresponds to the interrupt controller. And then there's also some fields to determine like the number of enabled channels and a couple of other things. When the MSI is fired, the device performs a memory write against that address, and then it writes, the corresponding value. So I would need to take a look at what's set up. I think what it will do is take the value and then add an offset to it. So if you fire MSI number 5, it takes the value, adds 5, and writes it to that address. And then the interrupt controller will receive the writes to that address region and then generate the interrupt accordingly. So MSIX, the idea is similar. You're still doing these these PCI Express writes to the interrupt controller, but instead the information is stored differently on the PCI Express device. So instead of eating up a huge amount of config space, there's pointers to locations in one of the PCI Express bars. One of them has a list of addresses, and then I think also the values that need to be written to those addresses, one of them per channel. And then there's another table which has the pending bits that indicates, there's, an operation that, that needs to take place here. Basically, if an MSI channel is triggered when it's disabled, then the pending bit gets set. So yeah, those need to be located somewhere in the bar space. So for Corundum, that means it'll probably sit in, the NIC control bar somewhere. So we'll have to hang something off of the internal, AXI light interface. And then we'll also need to update the PCI Express hard IP core configuration such that it points to these locations in the bar space. So that's the main changes that we need to do. And then the other thing is that we somehow need to, connect up the internal interrupt side of things. Right now, all of the channels just have, one wire per channel. And with 32, that's not really a big deal. But if we want to take the number of MSIs up to like 1,000 MSIs or something like that, well, having 1,000 bits just for interrupts is kind of silly. So we might need to come up with a different scheme for, merging these together. What might make sense is, instead of having all these individual kind of one hot wires, is having like some sort of a streaming interface where we can merge stuff together. So you just have, like a valid bit and then an index, and then, if you put the MSI number and then valid to indicate that we want to trigger that MSI, so we can merge all that together. But in that case, well, what if two things try to fire different MSIs at the same time? We have to arbitrate and properly support back pressure, and it makes things, a little bit more complicated in terms of handling some of the stuff internally, coming out of the queue management components that would actually be firing these interrupts. So, well, I guess it's specifically the event queue that'll be firing those interrupts. So, which I guess that's really not too different from how the events are handled internally right now. It would just be, using those for interrupts as well. I think that's something I need to revisit at some point anyway, is supporting some sort of back pressure on those channels. So hopefully I'll also be able to get around to adding that as a feature when I do the variable length descriptor, rewrite for the queue management modules, is to support, back pressure there, so we don't lose any events. Because that's definitely an issue I've run into a couple of times, where if you fire off too many events and you lose an event, then things get hung up. So yeah.
Is virtual functions a solution to this, or like the PCIe virtual function? Is that a way to get around the MSI?
So SRIOV, I think, requires the use of MSIX.
Anyway,
you can't use MSI with SRIOV. So, but using more functions maybe could give you more. Not SRIOV, just multiple functions. That's not something I've looked into much at this point.
Yeah, the advantage is then you at least have 32 interrupts, I guess, per function, which means that yeah, you can spread out the interfaces of the MQNIC, if the MQNIC has multiple interfaces over multiple functions, like Intel does it usually, I guess, and then have kind of a scaling effect there. It's actually, we noticed that last week, that I mean, I'm just stating what it's like currently, that if we have two interfaces, for example, on the SATC U106 board, then the interrupt is, one interrupt is firing basically for two event queues, one event queue from the first and one event queue from the second interface, of course. And that, yeah, in the beginning you think, well, doesn't matter, but if it comes down to speed, to receive speed, then I guess that it matters, because kind of if you're receiving on the second interface and don't receive on the first interface, I mean, it's the same thing the other way around, because but basically what you're doing, you get one interrupt and have to check both event queues, and checking an event queue which has no events, well, that's, yeah, cheap, but not that cheap if you want the maximum receive speed.
Well, I think one thing that will help is once I get the queue pointer right back, then checking the other event queue, that's just reading something out of host memory instead of doing an MMIO read, which at this point is not so great, having to do two MMIO reads instead of one. So anyway, yeah, I guess the other thing is that, I think right now Corundum is not totally set up to have multiple PCIe functions. That's definitely something that I need to investigate at some point. There are definitely some questions as to exactly how that would work and what that would look like in terms of how the HDL code is actually implemented, but that's definitely a point that we can discuss at some point.
Another thing I noticed is that the traffic I'm trying to receive is actually VLAN traffic, and the hash calculation actually doesn't take the VLAN into account, and they all went to the same interrupt. So I have a small patch that takes the VLAN into account as well when it's calculating hash. So I'll probably send that in next week or so.
Right. Yeah. So this is a modification to the RSS hash computation logic, presumably.
Exactly. Yes.
So as in it also takes it into account, or it skips the VLAN header?
It skips the VLAN headers.
Okay,
So
gotcha,
it
gotcha.
that
Okay.
use the IP source
Right,
port and
yeah.
IP address
Yeah. So
correctly for
at some point, what I want to do is write a new kind of packet header parser block, which will handle, I'm hoping, more than one VLAN header, and then also IPv4, IPv6, TCP, and UDP. So, and just extract kind of the relevant fields for, both for RSS to do its thing, and then also to support the checksum computation components as well, because we can compute and insert eventually the IP, TCP, and UDP checksums, so we have a more self-contained offload. So if we can put together a new module to do the parsing, then we can probably use that across several different components. So
cool.
yeah, that's
And also,
something
it might be an interesting idea to actually be able to use other bits from like the packet payload for like application level things, so you can take into account application layer data when calculating the hash.
Right. So this is where having that the tdest field merged in as part of the queue selection is going to be useful, because then the application can do whatever computing it wants and then set tdest, and then you can use that either instead of the RSS hash or in addition to the RSS hash, depending. So that's one of the things that has been on my back burner for a while, is to get that tdest field merged in as well, so that the queue selection logic can take that into consideration. So yeah, I mean, I guess on one hand, you could certainly modify the RSS logic to support that, but on the flip side, you could also just say, yeah, the application can just do whatever it wants. If you want to look at some other bits, then you can just make a copy of that block and pop it in the application section and drive the tdest field with that, and then that'll work. So yeah, it's just for the RSS hash, there are kind of standard ways of doing that. So I figured, okay, we're just going to implement the standard way, and then if somebody wants to do something custom, then you can implement that yourself. So yeah, I mean, I guess depending on what you're looking at, there could be a couple different directions you could take that in. So
And I guess while I'm at it, I'm using the card from Bitware, XUPP3R, and I guess you recently got one as well.
oh right, yeah, I did get one of those a while ago. That's been on my to-do list to put together a design for that one and get that all merged in upstream so everything works, because I think you must be working on an old on a fork of the repository that I'm not sure how up to date it is, right? So
I just recently updated, and it took me a couple of days to be able to compile it for the new card again.
right, okay.
I'm basically copying the VCU 1525 over, right, and just changing sort of the pin numbers on the card. And I tried doing 4 ports, but I couldn't get all 4 ports to work, so I'm just using like a 2-port configuration.
What, it's like a timing closure problem? It just doesn't fit if you turn on all 4 or something, or?
No, it's just like the other 2 ports I don't get any packets from the other 2 ports, so I'm not sure exactly what's going on. If I just compile them only for the other 2 ports, it works. But if I have all 4 ports configured in, I just couldn't get it to work. And
all right, well, I'll take a look at that. Yeah.
Okay.
Yeah, I have one of the boards. It's just a matter of finding the time to do that. Oh, I guess the one thing that I did want to do, this is another thing that's been kicking around on the back burner, is writing a module that will do the phi mapping, basically. So instead of those big if blocks generate statement thing that every FPGA core.v has in it, peel that off, because I've got a couple of, so it's like with up to 2 QSFPs, if you break them out, that's 8 channels. That's not too bad. But you go to 4 QSFPs, that's 16 channels, and it just gets much more complicated. I think there's probably a more procedural way to do that. It's going to be more flexible. So I'm planning on basically what I want to do is write that module, and then I'll use it, you know, on the ZCU, or not the ZCU, the XUPPR3, I think, whatever that board is. Yeah, and that'll make it a little bit easier to deal with. The FPGA you have on yours is a 9P, right? I think they
yeah.
they can
Yeah,
install different parts on there. Yeah, okay. All right.
Yeah.
Yeah, so hopefully I'll be able to get around to that soon.
Okay.
I got a lot of stuff on my to-do list, unfortunately. So, but I know it would definitely make your life easier if we were using the if you could use a board from upstream instead of having to maintain that separately. So
Right.
that's on my to-do list.
Okay, cool. Thanks.
I've also been in communication with a couple of guys at Bitware, and I wasn't sure if they would have, you know, boards that they could send potentially or what. So it seems like maybe they'll be able to send me a 250 SoC, but they're like, well, we have some of these Adelix boards. If you want to buy one, you know, we can give you a low price. I'm like, you know, I don't know if that's in the cards necessarily. It seems like they have constraints in terms of you know, part availability and whatnot. Otherwise, they might be able to provide more stuff. Maybe, I don't know. We'll see how things pan out over there. I think the sales guys have different opinions on what boards need to be supported and the utility of supporting, you know, more boards in terms of what they can provide. Anyway, yeah, I'll be working on this one hopefully soonish. I'll let you know when I have that operational. So, all right. Well, we're definitely made good use of the hour today. Does anybody else have any questions, comments, concerns, anything like that? Nope.
Yeah, just wanted to say thanks to Girai. We will definitely look at your page pool edition, and I guess we figure out where the memory is leaking, because we definitely hope for a better RX buffer recycling scheme. I guess that's the technical term. We did some measurements there last week, and it really makes a difference. We compared to Intel card in terms of RX speed and RX processing time. It seems to make a huge difference.
Yeah, I guess there's a couple of aspects to that. One of them is just being able to, you know, recycle the buffers, and instead of handing it back to the kernel and then having the kernel hand it back again. The other aspect that I've seen a couple drivers do is that when your MTU is set below like 2K, you can actually do 2 packets per frame, right? You can do one in the lower 2K and then another one in the upper 2K. And then this cuts your, you know, reshuffling around again by a factor of 2, because, and then you don't need as many pages in the first place. But I think in order to do that sort of thing, you need to do some fiddling with page reference counting or something. It seems like a couple different drivers that I've looked at have had very different techniques of screwing with the page reference counts. And I'm not an expert on how Linux memory management works, so I'm not going to touch that because I know it's not going to work. It's going to take a lot of iterating to make it work.
Yeah. I hope that the page pool is one clean way out of this.
So I think the page pool is not a complete solution. From my reading of the page pool API, it seemed like it was more about supporting XDP than recycling pages for the normal network stack. So I'm not sure if the page pool alone is going to do much, but I don't know.
I'm not entirely sure either yet. So,
but fortunately, this is entirely internal to the driver. It doesn't have anything to do with the hardware, so we can work on this parallel.
Yeah, actually, I was surprised when I looked at the different network drivers. there were so many different ways of just doing the same thing that
I
and
know.
like,
I think this is one of the reasons that I've even seen some chatter in relation to the page pool about supporting this type of thing. Because it's like, why is every Fappin driver reinventing the wheel in a different way when they could just kind of centralize all of this? Because it seems like most drivers are going to be able to benefit from this, and it's totally independent of whatever the heck the hardware is doing, and it involves screwing around with Linux kernel memory management, nitty gritty internals to make it work properly. I don't know.
I don't know.
But then,
is it a way where different network card vendors want to differentiate themselves because they have a better driver and they only implement it for their own driver? Maybe, I'm not sure.
I don't know. Well, I mean,
I'd
it's
say
possible
that's
that
for historical reasons, because I mean, in the beginning there's no general solution, so everybody does its own thing, and with time passing on, a general solution surfaces, and then that's going to be used, but that takes time, as usual.
well, I guess it's one thing besides that you got to separate each driver doing their own thing, even doing very similar things, versus implementing some kernel APIs that can do it in a standardized way that all the drivers can then just use. It would be nice to have something like that, the second option, but I guess it doesn't exist yet for whatever reason. I don't know why it doesn't exist though. I mean, I guess page pool is a step in that direction, but there's more that needs to be implemented.
Yeah, so
I've been
we'll
hoping
see.
that some network device driver expert will drop by at some point and say, hey, I can implement that. I'll be like, great, I'll send you a board.
Do you think it might be possible at some point to upstream the MQNIC kernel driver into Linux?
So this is something that I have been mulling over. There's definitely potential advantages, disadvantages, pitfalls, and whatnot associated with that. So this is one of the motivations actually for getting this little soft core running and trying to offload all the board management stuff onto the actual, or all the board specific stuff onto the board, because then it removes it from the driver. As it is right now, if you add a new board, you also need to modify the driver. And if it's upstreamed in Linux kernel, it doesn't work very well. But if we can get that, pushed onto a soft core, then that does simplify things a little bit, and then you can deal with new hardware relatively easily because you don't need to make any modifications to the driver. So in that sense, that's kind of freeing up one of the roadblocks for potentially getting it upstreamed. But on the flip side, once it's in the kernel, you can't really make modifications to it very easily. So if we need to change some of the register space configurations, then we have to, either it won't work with the version of the driver in the kernel, so you'll have to ship a separate one anyway, or you'll probably have to look into adding, support for dealing with multiple versions of different register blocks and whatnot. So even though we have versioning, right now it's basically just looking for specific versions, and if it doesn't see that, then it just fails. So if you were going to upstream something, you would probably have to look at multiple versions. The code would get more complicated and whatnot to deal with that. So, and then if you want to do any customization too, how would that work, right? If you want to, your application level functionality needs some customized code. So this is one of the things I was thinking about, being able to load like an extension kernel module, so you can use the upstream MQNIC driver and you could load your extension module for implementing some new functionality on top of that. So a lot of stuff to think about. This is kind of a long-term consideration. It would be nice if we could do that at some point, but and then I guess the related aspect is that we may have multiple drivers, like we have the Linux kernel driver, we may have like a DPDK driver and whatnot. So having the soft core thing to peel off the board specific stuff will definitely make it easier to support these multiple drivers. But yeah, in terms of getting stuff upstreamed, definitely not in the near future, because I think there's a lot of changes that need to be made, lots of improvements that can be made. Potentially once things have become a little bit more stable, then potentially something like that could be considered. But yeah, for the time being, I think it makes more sense to keep the FPGA code and the driver in the same repository. So
Okay, cool.
anyway, definitely something that I've been putting some thought into. All right. Well, the number of people seem to be kind of getting whittled down as people have meetings and stuff to run off to. So this has definitely been a good discussion today. Oh, you had something to say, Adam John?
No, no, no. I just was. No, I don't have anything to say.
Okay, okay.
I just was coughing.
All right. Well, if we don't have anything else to discuss, then we'll probably call it and close it down for this week. No other
Thanks
questions
a
or
lot.
comments or anything? But
Bye.
all right.
Have a
See
nice
ya.
day and a good night for some, and
Got to cover all
have
your
a nice
time
day for
zones.
others. Yes.
Good night, good morning, good evening, good afternoon, good day.
Yes.
Whatever time zone you might be located in. All right. Sounds
Bye.
good.
Have a
All
nice
right.
2 weeks.
Talk to you guys
Bye.
later. Thanks so
Yes.
much for joining today.
Thank
All
you.
right.
See you, Joachim and Alex.
See you. Bye.
See ya.